Well, good morning, good afternoon, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. We have, as always, a great webinar on tap today, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, just know you'll be able to access the webinar on demand. We'll be sending out an email a little later on today that will include a link to access the webinar on demand. And we are taking questions from the audience. So if at any time you have a question for our panelists, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your questions. And we'll take a few minutes near the end of today's presentation and go through the questions from the audience. And finally, we are going to be doing a drawing for 5 $50 Amazon gift cards at the end of today's presentation. So please stick around and we'll do that right after the Q&A session. So stick around and hopefully you'll be one of our lucky winners. Okay, with that, we'll go ahead and kick off today's webinar, which is securing microservices in containerized environments. Our speaker today is no stranger to the DevOps.com webinars. He is Tim Buntel, who is VP of Application Security Products at ThreatStack. Hey, Tim, how are you?
Hi, Charlene. Great. Good to be here, as always.
All right. Great. Well, you know the drill. I'm going to put myself on mute and let you get to it.
Perfect. So, hi, everybody. Nice to have you joining me here today. I'm going to quickly pop on my camera. So we were talking about this earlier, about how we do a lot of these webinars and folks say, you know, is it recorded, is it whatever? So I wanted to actually wave and say, hi, it's me. I'm actually here in Boston at ThreatStack headquarters. So would love to wish you all here in person so we could chat, but use the Q&A panel. Would love to interact with you that way. So now I'll turn that off and so I can get back to bad posture and slouching in my chair as we talk through this. So, you know, quickly about me, I look after the AppSec product business here at ThreatStack. I've been doing, you know, DevOps tools and developer tools for most of my career. So, you know, my focus has always been on folks like you know, professionals who are delivering value to customers through software and digital experiences. I love this stuff. I love all attributes of building great software. So happy to be having this conversation with you today. You know, we thought what we would do for today is, you know, we're really going to look at what does it mean when you're doing microservices, but specifically containerizing those workloads, and what does it really mean across the complete stack? What we're going to talk a little bit about this, what I call the illusion of simplicity that comes from containers. But before we do that, I thought what I'd do is walk you through a really quick example of a real world attack, just to kind of set the context of some of the sorts of things that if you know, go by undetected, can really lead to real problems. And this comes directly from our experience here at ThreatStack. One of the things that we offer is a cloud SecOps program, you know, where we have our own security experts using the ThreatStack platform to help our customers monitor and understand and have the visibility into their infrastructure. It's a great opportunity for me to go down and chat with the folks who are in that sort of part of the company to find out what's really happening out there. You know, we tend to get theoretical a lot of the times, and it's nice to go down and say, hey, what are some real world things that you're seeing and interesting cases that you guys are detecting that might speak to some of the trends that other customers should think about more broadly. So I'll walk you through one of these. I thought it was kind of fascinating, this real world attack that they saw, which was basically a cryptojacking attack. So, you know, someone coming in, trying to leverage your infrastructure for their own purposes. Hopefully they think in a way that you won't detect and basically drain, you know, your wallet to do their bidding, right? So through cryptomining. So let me kind of walk you through how this exploit worked. And then as we go through all of the other parts of the platform and talk about security, we'll echo back to some of these things so you can see where those lack of controls that we'll talk about later made an attack like this possible. So, you know, basically where it started is where these often start, right, which is out at the application tier with a website that's vulnerable to remote code injection. So folks are going around, they're prodding applications, they're looking for front doors that were left open. Generally, these code injection opportunities happen when an application is passing unsafe data. This could be any user-supplied data, forms, cookies, HTTP headers, and that sort of thing. And that'll go in, and without good input validation, that is something that the attacker can use to basically find a way to execute code on the host. So we see, for example, in Node.js, right, the child process exec uses a shell to execute commands. So if you have external input that executes a command directly, if you're not sanitizing, that could be a problem. So in this case, that's exactly what happened. So the person found a website that was vulnerable to this, and what they do is they are leveraging the backend to spin up a container that's going to execute this injected code. Usually what we're tending to see lately is in our SOC are attackers then passing commands directly to the shell within the Docker container, right? So spinning up the container, having access to a shell, and then using a script in this case to execute some malicious commands that are going to carry out whatever they're trying to do. The thing with a script, of course, is that you can kind of, not only do you have the controls of whatever, access that script has on the host, but you can kind of code up a number of steps, execute it really quickly, be in, be out, hopefully before it's even detected. It's happening in seconds, and they're assuming that people don't have processes in place to be looking for this malicious script. And again, that's exactly what happened in this case with the SOC. Since they were going to use this cryptomining, attack or kind of problem, the first thing they needed to do is kind of fetch the tools for that. So in this case, they're downloading this cryptomining executable with wget. They're getting CNRig. This is a pretty popular cryptomining executable. One thing that we've noticed that's appealing about this particular cryptomining tool is that it has the ability to auto-update. So once the hacker gets in and they set this up and they leave, they can forget about it, right? Because that executable is able to go and update itself as it gets new functionality. So think about this, right? So I'm gaining access to the system, I'm running this script in a matter of seconds, then I exit and I never have to worry about it again and sort of set it and forget it. It goes on without me needing to risk, accessing the system again. Next thing that happened, once this file was downloaded, they had to modify the permissions. So change it to be able to run the executable. And now remember, we're going to come back to some of the warning flags, but if you think about containers and microservices architecture, a core tenet is to make this immutable infrastructure, right? You shouldn't be changing components. So this should really be a strong signal that you've got a problem here. But again, by running this as a script, as part of a large infrastructure, they're hoping that nobody's watching and no one's going to find, evidence of these sorts of things happening. So once we've set up that executable to be able to run, they executed the cryptomining application, the /CNRig. An interesting thing in this particular case is they ran it out of the temp directory. So this is typical for malware. It's common for all users to have permissions to download and execute files out of temp. So again, this is a good potential red flag. If you're keeping an eye on your system, you shouldn't, by design in your applications, be running anything, or downloading files out of temp. And then finally, of course, CNRig spins up. It's doing this crypto mining, and it needs to have this outbound network connection from the container. That's going to go through the host and out into the public internet. And this is probably the most risky step. This is something that certainly would be setting off red flags, but it's the only way that the crypto mining can benefit the attacker, right, is to have that information sent out. But by this time, remember, as the attacker, I've moved on to my next target. I can do dozens or kind of hundreds of these same attacks, and there's multiple different ways to get the job done at each step along it. And this makes detection difficult, and they're hoping that they can carry it out broadly enough that they'll, at the end of the day, get enough of these deployed and running. So if you kind of think about this, think about some of the philosophies behind containers, and we'll broaden this to talk more about microservices in a second, but just focusing on the container, there's some pretty obvious warning signs here that should set off alarms, right? So why would you be running a shell in a container in the first place, right? You shouldn't run SSH in a server in a Docker container, right? There are other ways to do the kinds of things that you need to do. So use a volume for logs, or use signals to restart services and these sorts of things. There's really no need to be logging in. Why would you download an executable? If you're building software and you're deploying it in this container, you shouldn't be violating the notion of immutable infrastructure. It shouldn't be part of your application. Process activity from the temp directory we mentioned, right? So there's a lot of these warning signals out there, but the problem is folks often miss them. And they often miss them, I think, because we tend to have this, what I call this illusion of simplicity when it comes to containers, right? Containers have really revolutionized the way people are able to, independently deliver, develop and deliver software really quickly, because it seems like it should be pretty self-contained and pretty straightforward, right? You bake all of the things that you need to run your software into this nice, easily defined by code component that then just gets deployed. But what we see in reality is you can be fooled by this illusion of simplicity when it actually comes time to deploy this application in real environments, and that gets amplified in the case of microservices. So what do I mean by that? Well, if you think that all you have to worry about is the container, then you're missing actually more above you in the stack and below you in the stack in this cloud native environment, right? So you've got application issues when your application is deployed in that container. We saw this at the very beginning of the cryptomining attack, right? It was poorly sanitized input at the application tier. Regardless of the fact that it was deployed in a container or not, you had to address that. Then you have your containers that are sitting on your orchestrator. You've got some sort of cloud infrastructure that has its own control plane and user access, right? So thinking that addressing the concerns of container tier cover you are missing this up and down. Then in addition to the sort of vertical stack here, we have this horizontal plane of time, right? So, your software, no matter how you develop it and whatever DevOps or CI/CD approach you use, is going to be going through kind of multiple phases and multiple layers, right? So that one container might be going through a pipeline that involves other tools and processes. The code that defines those containers might be managed in the source code control repository. You might have different versions of those applications that are being deployed at different phases by different teams as it goes through. So you can see that one little block of container, now we're looking at a much more complex picture. Then we further break that down by, well, who's involved, right? So you've got a range of different people. If we're embracing DevOps, we're having cross-functional teams that each have individual components of responsibility to bring this application quickly to the process. This could be developers, it could be ops. In this case, we're going to talk about the security and the security folks. So quickly you get a third kind of dimension here based on the user. So you've got time, you've got user, you've got position in this full cloud stack. And then ultimately, we zoom that picture all the way out and enter this notion of microservices, where we have a number of applications that are loosely coupled, API-based. We're going to talk about them in a second. But all of that complexity gets amplified because not only do you have the stack over time for different roles, but you might have it in completely separate applications that are following their own pipelines. So you can see how quickly we're getting into a much more complex picture of things that we have to think about. And so this kind of notion of, well, hey, I'm doing containers, and containers are pretty easy to manage and they're pretty straightforward, can actually lead to a false sense of simplicity that we actually do see folks kind of fall for. So if we zoom back, I like to kind of talk about this in terms of the reverse of obviousness, right? So when it comes to thinking about how do I secure this entire environment, The container is oftentimes the most obvious, right, and fairly well understood. We'll talk about that in a second. But then as you zoom through some of these other things that we'll look at now, they may become less obvious, that you have to think about the security implications through all of these. So the container sitting in the orchestrator, the cloud infrastructure that's hosting that orchestrator and its containerized workloads, the inter-service communications that are going to allow these individual microservices to come together to be one, fully realized business benefit for your customers. Then we have the application tier, as we talked about at the beginning, and then finally one that I'm particularly interested in that I think is often overlooked is the pipeline that brings all of this into production in the first place. So how do you think about the security within the software development lifecycle itself? So basically, in talking to customers, again, I find these are typically kind of the most to least obvious. And yet when you start to have the conversations about security at each of these layers, people start nodding and saying, oh yeah, that's a great point. I hadn't necessarily thought about the communications between services or the pipeline. So let's drill into these one at a time, and we'll kind of talk about some of the risks that we see in each, and then some of the countermeasures or things that you might want to consider in your own efforts to build a microservices architecture using containers. So starting out with the container itself, again, as I said, this is one that a lot of folks have thought a lot about. There's a lot of vendors that look at this space. NIST publication on container security is now several years old, so if NIST is producing a 70-page document, that it's definitely not something that folks haven't really thought about. I did like this quote at the beginning. I kind of read the whole NIST publication, so you don't have to, but this one I pulled out I thought was particularly interesting from a DevOps perspective. Is right up in the beginning, they say, as a summary of sort of what should you do to secure microservices, they say, well, basically tailor what you do to support applications running in containers. So it's kind of non-advice, but it does point to something that I think is often overlooked, which is containers and securing containers is still part in most organizations of a DevOps transformation. So these kind of organizational and operational cultural issues that we're dealing with generally in DevOps applies to containers just as much as it applies to any sort of infrastructure. Especially here where containers could create kind of a false separation between teams. The developer kind of creates their Docker file and ops has to deploy it, right? And that can point companies in a direction that breaks down some of those good, kind of collaborative processes that are in place with DevOps. So don't forget your DevOps behaviors when it comes to containers. Now, the risks specifically generally fall into these two categories. There's compromise of the container itself, or there's sort of misuse of the container to attack other containers. So this is often, permissions and accessing other containers via these services. Most of you probably heard just about a month ago, I guess now, the Run C CVE, the vulnerability that got published, where attackers could essentially gain root access to the Docker container through this vulnerability in Run C, right? And that's as central a piece of technology in deploying containers as they come. And yet here you have a really significant container escape vulnerability that was published there. This would kind of allow that malicious container to overwrite the host Run C binary, and it could let an attacker gain root level code execution capability, right? So these kinds of container compromises are definitely out there. What you need to do are pretty clear from the NIST guidelines and what we see in the vendor landscape and ecosystem. Kind of breaks down to these three big countermeasures. The first one is sort of thinking about the container image, right? So make sure that you're thinking about the host OS and containers appropriately, right? You don't necessarily want to use a general purpose host OS because a container is different than a general purpose, kind of bare metal deployment. So a hardened image, you maybe want to have a minimal OS with only what's required to run the container. We talked about SSH servers back up at the beginning. If you don't need it, why put it in your host image, right? Disable that unused functionality, and it's going to reduce the attack surface. Then once we have the hardened images, we need sort of tools and processes to kind of take the vulnerabilities and configuration settings into account, right? Policy enforcement is a primary one here, where you want to make sure that non-compliant images can't be run. And then how do you automate that policy enforcement when you have a highly automated deployment pipeline with the containers? So making sure that you apply those policies is quite important. And then the third part is to recognize the fact that runtime defense tools are going to have to be different in a containerized world than they would be in other environments. Typically, we see things like WAFs and IPSs that come from more traditional implementations that might not be able to handle, say, the scale of containers or the rate of change that you have when you're frequently deploying these new container images. Or maybe they don't have insight into container level activity, right? So utilizing security solutions as container native to monitor that environment will give you sort of more precise coverage there. And that happens to be one of the things that we look after at Threat Stack, where we're able to do things like know when new Docker images are pulled, and who's pulling them and who's running them and where, right? Or identifying the kinds of anomalous user or process or file behaviors that we saw in the cryptojacking example. By being able to monitor deeply into the container specifically, we can look out for those kinds of warning signs that we saw earlier. A couple of things that I think are always worth pointing out as well is this notion of immutable infrastructure, right? Containers should be immutable. So you shouldn't have anything happening in the environment that's going to change them after they've been deployed. You set them up, you configure them, and then they stay that way. We also talk about Linux best practices in containers. Obviously, a container is a little different than other Linux, sort of environments. But generally, we have decades of experience of what are good best practices when it comes to security in Linux, and many of those can be applied to containers just as well. So while you're thinking about containers, don't necessarily throw out all of that learning that we've taken in the back. If I can summarize this, again, this long NIST document, for me, really boils down to these 3 points. So use a purpose-built image that only makes available the functionality that your application needs. Keep it slim, keep it trim. It's going to give you benefits in terms of runtime performance and size anyway, but it will also reduce a lot of security problems. Then once you have those purpose-built images and you're managing those through an artifact repository, enforce their use. If your developers are still able to go out and pull down some sort of container that they find online, they're going to have a vanilla node container, but they pull something down that might have other code in it, you're defeating the purpose. And then finally, monitor when you are running those containers for inappropriate behavior. So really, for me, these are the 3 big ones. And now you don't have to read the NIST document unless you really want to. So let's zoom out a bit to the orchestrator tier. And again, to be clear, when we're talking about orchestrator at this point, we're really talking about Kubernetes. While there are some other orchestrators out there, basically by now, CNCF, has pretty much identified for us that Kubernetes is it. Generally, the risks that we see here are either control plane or around sensitivity of workload. So we had the Tesla breach a year and a half ago, I think now, where the dashboard was unsecured, right? So this is, clearly a problem with accessing this control plane where it's not in the application workload, but exposes someone to either unauthorized access or unbounded access, which is a big issue where a single orchestrator might run lots of different apps. They might all be managed by different teams. There shouldn't be one administrator, right? So you need to think about bounding the controls that those administrators have. And that touches to the second point, right? Which is all of these different teams might be delivering applications that have really quite different sensitivity levels. You might have something that's relatively low security risk and low sensitivity being orchestrated at the same time with something that's quite high sensitivity. And we don't necessarily think about that because we're thinking about the applications differences, but we're not thinking about the fact that a single orchestrator might be managing both of them. And you want to make sure that the access is appropriate for those. So when it comes to countermeasures, the ones that we see that tend to have the most impact, I hate to say it, but staying current on the versions is really critical. The dashboard access in the Tesla example, if you upgrade to the latest version of Kubernetes, they are really good about addressing these kinds of things and bring it out in new versions. But as many of us know, upgrading Kubernetes is not the easiest thing to do. So a lot of folks kind of step back and say, well, I'm going to delay moving to the newest version because it's really difficult, or I don't have the personnel or the expertise to do it. But you're leaving yourself open to these problems. Multi-factor authentication is one that has been available for a while, and yet it amazes me how many folks are just using a password to control their control plane there, right? And if you insist on multi-factor authentication for your Gmail account, why wouldn't you do it for the orchestrator that's managing the workloads of all your apps, right? Least privilege access model, I think, has been well covered elsewhere, but definitely something to keep in mind. Only provide permissions to do the absolute minimum required tasks. Within your cluster, think about the sensitivity of those workloads and isolate deployments from each other appropriately for that. So you don't want to have your high sensitivity PII accessing applications running alongside something that's less sensitive. And then finally, think about how you handle progressive delivery. James McGovern, James, has been using this phrase lately, progressive delivery, which I really like, to cover all of those scenarios of things like blue-green deployments and dark launches and all of these ways of progressively getting software into an environment. And think about how you want to address those at the orchestrator level too, in terms of bringing functionality into market rather than all in one wave in these sort of progressive ways. Okay, zooming out a little bit further, generally these containers that are being orchestrated by kubes are deployed somewhere in some sort of cloud infrastructure, right? The big ones, of course, Amazon, Azure, Google Cloud. Within them, however, there's also this kind of spectrum of ways of deploying those workloads within them. So Amazon, for example, you have everything from the kind of less abstracted, more highly managed, deploying it yourself on EC2, all the way up through this spectrum of ECS and EKS for slightly more managed using Kubernetes, all the way out to a highly abstracted way of running those workloads with something like Fargate, which I was at an AWS event recently, and they're now talking about Fargate as serverless, right? They're saying Fargate is serverless containers in the same way that Lambda is serverless functions. So thinking further about abstracting all of the control layer in the containerized workloads. Now, what this means in terms of risks, again, typically the things that we see at this kind of infrastructure and the control plane for that fall into these two big categories. So either unauthorized changes or lack of visibility and control into what's happening there, which is what we saw in the crypto mining example in the beginning. The unauthorized changes are something really to be aware of as well, with things like instances or security groups or changes to S3 buckets or access keys, because these really open up capabilities that are going to touch not only one application, but potentially an entire application workload, right? And don't forget, you don't necessarily need to use the applications themselves to do things, for the hacker to be able to accomplish their goals, right? So in the crypto mining, we saw that container was opening network access directly, but you can do things like data exfiltration directly through an AWS API. So ignoring the control plane in favor of only the application in the container does put you in peril. Now, so far, all of this can be applied to a single monolithic application that's deployed in the container. But what we're talking about today are microservices, right? And so if you think about microservices themselves as the sort of standard definition of a bunch of services that are decoupled and they're ephemeral and stateless, and they tend to have lots of different languages with their own deployment and delivery pipelines. They're all API driven. They're over this sort of communicating over this network. It basically boils down to what any ops or manager's nightmare, really. Here's a bunch of frequently changing applications deployed on unreliable networks. Like, who would want to sign up for that? It's a pretty horrifying proposition. All of the benefits that we get are ultimately up against this fundamental huge challenge that is really scary. So more and more, what we're seeing adopted lately are service meshes. A lot of our customers are having conversations about how a service mesh can fit into a microservices architecture. Istio, probably the one that's leading here now, but obviously a couple of other ones. The Envoy agent is available across the different service mesh implementations. And really, service meshes are trying to deliver a certain set of benefits that address some of those fundamental concerns or failings of starting to do microservices at scale in an organization. So things like service naming normalization, so developers can refer in a more abstract way. Resiliency features, being able to automatically handle things like retries to services or timeouts of tries. The kinds of things that developers would have to bake into their application can be abstracted to the service mesh to make developers able to focus more on high-value business functionality rather than this kind of low-level functionality that's just required to make the microservices architecture work. Traffic routing, traffic shaping, this could be for your progressive deployments that we were talking about a minute ago, or maybe you want to have certain customers have access to certain deployments of your application based on their SLAs that you deliver or whatnot. You can do all of this in a managed way with service meshes. Observability and monitoring is improved because you're pulling in signals from all of these microservices that you can monitor in a single place. But for the topics that we're touching on here today, security is another really key benefit of service meshes. They tend to differ a little bit from service mesh to service mesh, but Istio is a good example. It has a number of really key security features that are built right in. So for things like man-in-the-middle attack, you have these separate microservices that are talking to each other across a network. That's a pretty good candidate for a man-in-the-middle attack. So you want to think about encrypting the traffic. That's handled by Istio. Access control, sort of being able to have flexible access control. You really want to have these fine-grained access policies and mutual TLS to make sure the services are who they say they are. That's baked into the service mesh. And then this notion of authentication and authorization and audit tools to understand really who did what and at what time. This is a big one for compliance needs and security. That gets handled by the service mesh as well. So from our experience with some of the challenges that organizations face when they start to do microservices at scale, some of the features that are coming out through a service mesh is really quite powerful. So I'd encourage you, if you are doing microservices and haven't looked at the capabilities of service mesh, definitely take a look at that. Okay, so we're getting a little bit higher out now. In the tier, obviously lots of folks think about applications, but maybe not so much when it comes to the differences in a microservices architecture. But fundamentally, for me, the big problem in the application tier is that we continue to have the same application security risks year in and year out. And for some reason, which maybe is a topic for another webinar, why that's the case, but they continue to persist. I love this study that just came out yesterday. The University of Bonn in Germany, they basically asked a bunch of Java programmers that they reached out to on Freelancer. So these are, kind of people who are out there bidding their development services to the world. They said, okay, well, write a user registration system for a fake social network, right? So really basic task, just user registration for whatever. So of the folks who took that job, it was 43 developers took the job. 18 of them, so that's 42%, sent their initial project that stored passwords in plain text. So these are supposedly professional developers in 2019 building something as basic as a user registration system, and they're storing passwords in plain text, right? And then even those, once they got feedback that said, hey, you have to take security into the account, they came back with things like, oh, well, we're using base64 or MD5, or they're talking about encoding and hashing instead of encryption, right? So even something as simple as this, or as I point out here, injection attacks, SQL injection, we've known about these things for so many years, and yet we continue to have these same vulnerabilities time and time again. It's the same usual risks at the application tier. Input sanitization we saw in the cryptomining example, misconfiguration, leaving default settings on backends and servers, use of weak cryptography or no encryption. Third-party component vulnerabilities. This list is really well known. The countermeasures at the application tier are really going to be the same as we always do. Plan early, do threat modeling, think about your attack services, build testing into your CI/CD workflow. Have a way to monitor and catalog your third-party components so you can watch out for known vulnerabilities in them. Protect your application at runtime, right? So these are the same things that we're always been telling developers for years when it comes to application security. But it's this bottom line that is most important to call to your attention. What we were describing in microservices just is a way to take all of these usual risks and amplify them, right? So now, suddenly to deploy one application, you might have 5, 10 different microservices. So all of these usual risks have to be addressed across all of those separate applications. And they might be coming through their own individual CI/CD pipeline. They might be polyglot, so they have different languages. You might have one AppSec guy who's great in Java, but what happens when a team is doing a microservice in Ruby? And then think about not just the typical kind of north-south network traffic that you need to protect against in a traditional web app, something like looking at input sanitization through a WAF, for example. But in a microservices app, you have to think about the east-west traffic, right? So that service-to-service communication. We've seen examples of payloads that come in to the entry microservice that are benign, right? So there's nothing risky about that payload as it comes in. But with the attacker understanding how the payload changes as each service does some processing and passes it on to the next service, they're able to use that transformation to ultimately turn that benign payload into something that's risky, right? And that's something that a traditional web application firewall, a traditional WAF that only looks at the north-south traffic isn't going to help you with. So you have to think about input sanitization and all of these good practices across your microservices, not just with a firewall in front of them. Now, finally, we'll talk about the development life cycle of these applications. We often talk about this secure software development life cycle. Don't get me wrong, this is great. I've been involved in tools and approaches to making the development process more secure. We talk about shift left or stretch left, of bringing security practices earlier in the process and embedding them throughout the entire CI/CD pipeline rather than bolting them on at the end. Now, this is all great for the software that goes through that process, right? You're testing the software with DAST. You're thinking about attack vectors and threat modeling. You're getting third-party pen testing on the app as it goes through. But what about analyzing and monitoring the actual processes and tools that do that, right? So not just the application itself, but the tools that allow that code to move through this process and make sure that there are controls in place that gets done safely. This, I think, is a big missing piece that, again, in a microservices architecture becomes even more complex. So these I would refer to as sort of development lifecycle or CI/CD pipeline risk. So let's focus, right at the beginning on builds, right? So the CI part of this. This is one for me that is just a really shockingly overlooked piece of securing your kind of applications. And this is the build servers, right? So they're typically not at the top of the list for environments that security teams are looking at, but they're really, if you think about it, they're critical transit hubs. Everything is moving through the infrastructure that runs your build systems. They regularly need to access other parts of your infrastructure. They have to have access to your servers, to S3. They have access to your CDN as these kind of core transit hubs. And there are things where, keys could be left on disks that could be accessed by the build server, and that could allow attacker to sort of pivot their attacks into other part of your infrastructure. So access to all of these things is obviously high value and critical, but frequently overlooked because you're focusing on securing the production infrastructure and not your development infrastructure. Then some of the things that we mentioned about microservices certainly come into the picture here as well. So the fact not only that you have to think about securing that build infrastructure, but in a microservices environment, you might have multiple build infrastructures that you need to secure. You might have teams that are doing their own pipeline that's entirely cloud native. Some are doing on-prem, some are geographically distributed. So you have to think about how do you create policies and then enforce them across these multiple pipelines. Who's going to review those and do enforcement? In the pipeline, we have to remember too about things like version drift. As you're shipping out multiple versions of these microservices, it does set you up for a risk of versions getting out of sync. We see this especially in third-party components. And then polyglot challenges, I often encourage folks to not forget about when it comes to software development lifecycle. This notion that while it's liberating for the development teams to be able to use whatever language they want, it can be a really big security challenge for things like secure code reviews. So make sure you account for that in the complexity of the microservices. While you want to empower the teams to be innovative and drive innovation, you also have to make sure that you're able to understand the emerging tools and technologies that they're going to do, that they're going to leverage to build them. Countermeasures. This one is actually quite simple for me. It really comes down to think about all of these environments and all of these pipelines exactly as you would production, because there's plenty of high value targets to be found there as well. So secure your environments the same way you would as production, and monitor your environments. If you're concerned about unauthorized access or file integrity monitoring on your production environments, why wouldn't you also be concerned about that in your development environments and looking for those red flags and risk signals? So hopefully, you're not in the same way that we've hopefully moved to the point where we don't think about application security at the last minute before going into production. We also want to make sure you're not just thinking about securing production environments that come at the tail end. You hopefully wouldn't be doing that for apps, so also don't do that for your build environment. Right? Great. Just take a sip of water here. I know this is heaps and heaps of information. It's a bit of a fire hose presentation for everybody today. I see some good questions coming in, so I want to leave Q&A time there. And hopefully, if some of these topics are of interest, we'd love to go and drill in on individual ones in future webinars, so we can take a more detailed view of how some of these risks are manifest, what we see in our customers and across the landscape, and then some of the countermeasures that we've found to be most successful. But for now, if I had to kind of summarize a couple of takeaways, containers, we think that this is a pretty good approach, right? So make sure that you have a trusted and carefully thought out container image. Not only use it, but make sure you enforce its use as well. We want to balance the freedom and the speed that we give developers with a reasonable control over that. So create and use those. When it comes to monitoring, make sure that both the container and the microservices, you're not just relying on the same approach that you've done in the past, because these architectures are different, and you want to make sure that the tools that you're leveraging there are familiar with how it's different. Make sure to secure your SDLC resources. Again, this is one that I'm taking as a personal crusade in 2019, is to talk about build service and the importance of securing these environments. Keeping current, we talked about the challenge of updating Kubernetes and updating software in general. If you're not familiar with the CNCF, the update framework project, do check that out. That's trying to address a lot of these challenges of managing and keeping versions current. And then we've heard the term, shift left for months now, or years now, I guess, in the context of DevSecOps. I prefer the term stretch left because it's less of a lift and shift and sort of saying, oh, responsibility for security is now on developers' laps. I can sort of wipe my hands clean of it. But it's really this notion of kind of spreading the responsibility of security across all of the participants in the development process, whether you're security, developers, architects, operations, and so forth. Right. So hopefully that's kind of a good summary and overview. I think we've got some time for a few questions. Charlene, I think you've been keeping an eye there. Yeah.
Yeah. We've gotten some in, but there's plenty of time. If you do have a question for Tim, please go ahead and use your GoToWebinar control panel and submit your question. We'll get to as many as we can. Let's go ahead and kick them off now. The first question is, what is unbound access? What do you mean by that?
Yeah, so it's a great question. So this ties on to this notion of the principle of least privilege, right? So not only do you want to control the specific instance of access, but you want to control the reach of that access. So making sure that it's bounded to whatever the workloads are that are appropriate for the user account or the workload or the service itself. So you want to make sure that you're controlling authorized access and the boundaries of that access for even folks who are authorized. Does that make sense? Yeah, so not just, a black and white, can you come in or can you come out, but once you're in, even if you're authorized, making sure that you're able to do things that are appropriate for the role that's authorized. Okay.
All right, great. Next question, I guess along the same lines, what is stretch left?
Yeah, so it's this very notion here that I'm going to make, again, with build security, build servers, one of my kind of takes on this for this year. The notion of shift left came in through kind of conversation in DevOps about getting security built more in. So the way we have dev and ops as a portmanteau, development and operations, we split security in there. So development, security, operations for DevSecOps. This phrase of shift left got applied to that movement, which is good in principle, right? So the idea is sound, which is saying we shouldn't just bolt security on at the last minute, right? So, don't wait until you're shipping your software to say, oh, hey, what have we done about security? You need to think about integrating security all along the process. So I love that principle, and I'm a firm believer in it. Unfortunately, the term shift left, I've seen in a lot of cases be misinterpreted as meaning make it the developer's responsibility, right? Full stop. And a lot of folks say, oh, wow, we've really struggled with security. We're trying to bolt it on. It's this bottleneck. So what we'll do is we'll just tell developers that they have to worry about security now. So that's shift left. We're going to shift security into the developers' laps, and suddenly they're going to have to figure it out for themselves. Obviously, this is kind of a ridiculous solution. And not only are developers in many cases not equipped to be able to do that, but it's really, for me, counter to the philosophies of DevOps, where it's shared responsibility throughout a cross-functional team. So I like the term stretch left or smear left, or something that gives more of the impression that we're not kind of lifting responsibility and dropping it somewhere else. What we're really doing is we're weaving responsibility into every phase of the process. So you're still going to have security. You're still going to be thinking about security at runtime. It's not all going to be handled at build time, but you do have to think about security both across all of the stages and across all of the participants. So stretch left, it's kind of the Tim Buntel take on shift left. I'd love to hear if folks like it.
All right, awesome. All right, guys, we have 10 minutes to the top of the hour. I think we can get maybe two more questions in. So next question, does the number of microservices or level of decomposition have some influence on security?
Yeah, so, lots of the issues that we've seen here happen when you have, more than one service. Right, so something like inter-service communication and the need to encrypt communication between services, or mutual TLS for ensuring that services are who they say they are, for example. Right, that is something that you have to think about, whether you have 2 microservices composed for your application or 20. Right. However, the scale of the challenges comes into play when you have a lot more microservices. So monitoring, there's just simply more stuff to ingest. The polyglot challenges, I think, can become more acute when you have more and more microservices. Chances are, if you have 20 different services, the likelihood goes up that you're going to have different languages, or you're going to have different frameworks among single languages. So I think you do have to consider the balance and the trade-off of the benefits of lots of microservices versus fewer. The idea of breaking up a monolith into smaller chunks that allow the team to be more agile and faster moving and delivering value in independent streams totally makes sense, but it comes with some added complexity, and we have to think about the point at which the complexity starts to outweigh the benefit that you get. So I wish there was a hard answer or a specific answer, but generally that's what we see is some of these things have to be applied, whether it's 2 microservices or 20, but you do have to think about the creeping complexity at scale.
All right, great. Excuse me, we do have a request. If you could share or put up the slide that has the warning signs on it. Sure. Annie would like to take a look at that again. And while you're doing that, I'll go ahead and throw another question out at you. What about the
warning signs back in the container hack? Was that a sort of red flag?
Yeah, I guess so. She just said the warning sign slide. So.
Yeah, that was some of the things that in that particular cryptojacking exploit. These were some of the things that our Security Operations Center personnel were able to notice that allowed them to detect and prevent that attack from going forward, but that lots of other folks maybe wouldn't have noticed, and yet really should be setting off some danger signs if you're in a containerized microservice.
Okay. All right, great. So I think we have time for one more question. What about the case of hybrid architecture? So some on-prem and some cloud, for example.
Yeah, great question. So a lot of the conversation here was talking about sort of cloud native. Absolutely, we do see folks who are doing microservices applications that might be deployed in different on-prem versus full public cloud. I would say things that become even more important are things like the inter-service communication challenges, making sure that services are who they say they are. You're going to have different types of control planes to think about versus, the fact where if you're in a single cloud provider, for example, you just have to secure, whatever the infrastructure control plane is for that one. So again, it's this notion of the more environments, the more potential complexity, the more you have to think about what to monitor and what to be able to respond to. That said, hybrid architecture is a great benefit of microservices, right? And we do know that lots of folks don't have the luxury necessarily of building applications from scratch. And we've seen lots of people who are very successful taking a traditional monolithic application that might be running on-prem and gradually carving off appropriate workloads from that and deploying them as microservices. So it's not going to be unusual to see that, where you might have a more monolithic collection of application functionality running on-prem, and then maybe some microservices in the cloud, whether those are in containers or maybe something like Lambda, right? Serverless is a good candidate for that too.
All right, great. Unfortunately, I think that is all the time that we have for the question. So I do want to thank everybody who did submit a question. If we didn't get to it, I apologize, but please know that we will be, the folks at ThreatStat will be getting a list of all of the questions that come in, and I'm sure they'll be more than happy to follow up with you offline. And before we close things out, I do want to do the aforementioned gift card drawing. So Tim, if you'll give me a drum roll, please.
Here we go. Very exciting, and I'm not eligible, so I'm upset.
That's right, sorry. Okay, so first winner is Amita Kasai. Congratulations, Amita. And let's see, second winner is Trevor Martin. Congratulations, Trevor. And third is Yower Radiance. I apologize if I mispronounce anybody's name. Congratulations, Yower. And our fourth winner is, let's see, it's Sekou, S-E-K-O-U, Diabate. And again, I apologize if I mispronounce your name. Our last winner for the $50 Amazon gift card is, this is an easy one, Jeffrey Seelnacht. So congratulations to all of our winners. We'll be following up with you offline to make sure that you get that Amazon gift card. And again, thank you for being on today's webinar. And just a quick reminder that today's event has been recorded. So if you missed any or all of it, or if you just want to listen to it again, you will have the opportunity to do so. We'll be sending out an email later on today that will include a link to access the webinar on demand. And the webinar is also going to be on the devops.com website, so you can always find it there under the webinars section. Just click under webinars on demand and it should be right there waiting for you. And while you're there, please check out the other webinars that we have, both upcoming and on demand. Hopefully there'll be one or two that pique your interest. Tim, as always, awesome presentation.
Yeah, thank you so much for having me. Look forward to coming back soon. And
yeah, hope so. Hope so. All right.
Thanks, Charlene.
Thanks for being here. And also want to thank everybody for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody.